for taking some actions, and also how do you troubleshoot the network when you identify a problem. So this is a kind of a high level agenda. Though, so first I will take like first 15 minutes or so to kind of quickly talk about our Blue Arcus and also our kind of the core network software architecture and other things as well. So let me share my screen with a different presentation. Okay, so I'm sorry, I think it's a different. One second, I'm trying to. Okay, a little bit about Blue Arcus so that everyone is familiar with what we do, who we are, all those other things. So typically, Blue Arcus, we are based out of Silicon Valley, based out of Sunnyvale, California, and we kind of offer the core network technologies all the way from 2G to 5G, where we primarily focused on the 2G and 3G technologies initially, mostly focusing on the Pacific Island nations, and more focusing on the 2G, 3G IP-based core network technologies. And eventually, we pivoted into the 4G, 5G technology. Now we are spread across the globe. So our key use cases here is we focus on the public cellular networks, like a Tier 2, Tier 3 MNO networks, MVNO, and fixed wireless, mostly focusing on a 4G fixed wireless or a 5G fixed wireless, and primarily and also about private 4G and a private 5G networks as well. So we have been in the business since last 10 years, and we have all the way around 120 plus or around 150 production deployments. Either you include the commercial deployments or the lab networks kind of stuff. And we are spread across the globe, all the way in the US, India, Australia, and Philippines. So in that way, we were able to provide the support 24/7. So what is the customer value that we bring in is, yeah, we have the networks that are kind of running for a while since 2017, and it's a field proven. Number two is we kind of tailor the networks so that it's not because when we talk about the solutions, I will go over a different flavors of the solution so that you can actually tailor the networks depending upon the deployment type and also the use case. We do have a strong integration of the 3GPP, 4G, 5G core network to deeply integrate with CGNAT, DHCP, and all those other enterprise flavors as well. And we do have an included FCAPS platform where you can use it for management of your complete fault management, configuration, performance, and also the onboarding users and everything. And not only we do support the data and voice functionality, we do support a lot of other advanced use cases, like integration to mission critical services, like a mission critical to talk, E911, and all the other voice related use cases. And since we are kind of presented spread across the globe, so we were able to support our customers 24/7. So this is typical our product offerings where we have a converged 4G, 5G core. Either you can use it as a 4G or a 5G or a combination of both. because most of our modules are a convergent modules, and you can connect the 4G radio or a 5G radio at the same time, or you can pick and choose which radio to connect. And we have a inbuilt IMS where we can use the IMS for internal voice over LTE or VoNR calls or Vivo IP calls, and also use the IMS to integrate to the traditional PBX systems over a SIP or something, so that you can have a communication, seamless communication across. And since I think our products are like an ingredients, but we build our solutions based on the products. And primarily, we have two verticals. One, we focus on the carrier business, and where we talk about these MNO users. And the number two is also about the fixed wireless access networks. So those are typical CTO-based organizations where they are like an MNOs, and they offer the service to the end customers. Number two is we work with a lot of system integrators and enterprises to because they have a specific use case, and then where we offer them a private 4G or a private 5G network, so that it can tailor or it can cater to a specific customer use case. And so this is our kind of an enterprise advantage. I mean, of course, most of the networks are sunsetting all the way 2G, 3G, because still there are a little bit of 2G is there for the IoT stuff. But mostly, most of our networks are pivoted towards 4G and 5G. And we do have a carrier grade a core network. Why I said carrier grade is we do have a redundancy option, so you can have a network, because most of the carriers are like an MNOs. They need a very reliable system, and also resiliency should be there. So what we do is most of the MNO networks, we do have a geo redundant kind of a deployment, where you have one data center and then you have a second data center, and the traffic is either shared between the data centers, or you can use it like a kind of a backup primary and a secondary. Number two is open interfaces, integration with enterprise LAN, WAN, and the RAN opportunities as well. And also, we do have a modular or a cloud native. Like if you want to deploy on-prem, we do have on-prem deployment, or you wanted to deploy in your private cloud or a public cloud, you have an option. Because for us, it's like a bring your own kind of an compute. So either you have a compute on-prem, you have a data center, or you can pick AWS cloud. But if you don't have any preference, and we can also put it in our cloud, or we can supply you the hardware and other things. And what we do traditionally, it's like you deploy in a data center and you connect all the radios. But now most of the networks are becoming more like a hybrid nature. That means you put all the control plane in your data center or AWS, but the user plane is always kind of do a local breakout. That means you have a radio or a multiple radios, and all these multiple RAN networks can be, kind of do a local breakout, or you can connect over a Starlink. So you send all the control plane over Starlink, but you can terminate all the data directly to the internet using a local breakout. It's like a typical hybrid setup. And we do have a flexible rollout tailored for multiple use cases as well. So this is a kind of an enterprise advantage that we have. We talk about the solutions at a later stage there, where we also kind of focus on how are we going to integrate to the existing enterprise networks. We can have a UPF that can be centralized, or you can do an edge-based UPF, so that you can, terminate all the traffic locally. And inbuilt policy and QoS control. So you can manually assign a different QoS directly using the management platform, or we open up an API, REST API, so you can invoke all your policies and everything towards it. And as a part of our management platform, which comes by default when you purchase a core, is we give you a complete observability about your KPIs, our performance, your usage data and everything, which we'll also kind of go over it when we demonstrate the management platform. And mostly we also support the native voice support. So either you do a Vivo LTE or a voice over NR, or you can install an app on the phone, enterprise app, and do a communication because our AMS can also act as a SIP server for you. So this is one of the tailored private cellular network kit. So it's like a kind of a Pelican case. So you can build our Pelican case. What we do is we bring in our a core and a RAN partner and a router. So you can make your own kind of a Pelican case. It is mostly for lab deployments, mostly for tactical deployments, or mostly you can offer this, either it can be a ruggedized design or it can be a non-ruggedized design. It doesn't matter, but we do have some kind of a form factor that where we offer this for labs and for these temporary deployments. So we always call ourselves as only a software company, bring your own hardware. But if you wanted to look at, okay, what is the kind of a compute that you need for like a kind of a, like let's say you have 100 subscriber or you have 1,000 subscriber, this is a typical kind of a sample that we put together. So based on this, you can derive the compute requirement. And all these flavors we do support redundancy. So let's say you have a use case where it is a kind of a lab system for 5G, where you want to connect one radio and you maybe your number of users may be 100 or 200, something like that. You can opt for that kind of a mini option, and the hardware doesn't cost you much, maybe 500 bucks or something, for example. And now you want to build as a redundant core, you put two boxes there, so we can automatically give you redundancy. So this is the kind of a hardware spec that you are looking at, but we only noted it for like a 10K to 20 Gbps UPF throughput. But we do support up to 1 million or 2 million kind of the user base with a 100 gig throughput per UPF instance. So this is an embedded core option that along with Baicells, that we have this kind of an embedded network in a box, let's call it in this way. So what it does have is you can have either it's a complete 5G, for example, so where we have a complete core inside, management platform, everything is inside. So you only connection you need to the external world is either internet, if you want to use internet, and the number two is you need power and RF. So everything is there, like no dedicated backhaul needed except for internet services. And we do support the multiple APN. And also we do support an API. So if you wanted to manage it externally using an API, you can also manage. So you don't need anything in the cloud. You don't need any central component. You take it, you deploy anywhere, you just plug in like Starlink or anything, you just connect power, and then you have access to a complete private 5G network. So, and now getting into the MNO or MVNO or a kind of a fixed wireless nature of it. Here, it's the same core, but it acts differently because when it comes to the MNO or FWA or fixed wireless, now you wanted to have a lot of other integrations to the billing systems and integrations to the roaming. Like if you want to connect your existing small MNO network to the other public network, you can do a standard roaming interface. And you want a lot of APIs to be accessible so you can know the complete visibility and observability of the whole system, and a very full-fledged policy and a QoS control, along with analytics, which I will show you as a part of the management platform. And of course, for MNOs, they do want a native dialer support because most of the networks that we deployed are the either an NSA or SA deployments. Mostly the voice is VoLTE. And we do have a local switching option. So if you are deploying this kind of a network only to manage your local services, so you have an option to do that as well. So we have multiple operator network references that we have. So where these are kind of a sub 1 million kind of the users, that is our sweet spot. So looking at our core network architecture, typically this is our kind of the core network modular approach. Modular approach in the sense, if you look at all the components that are VNF or CNF in the middle, those are the Blue Arcus components. From the infrastructure side of it, we are very agnostic to the infrastructure. You can pick your VMware or a cloud native Dockers or anything, or on-prem COT server. It doesn't matter for us because we do support all the flavors of it. And if you look at the modular approach, that means, let's say you already deployed. We do have a lot of requirements where the network is an existing network, but they wanted to upgrade their network, add the 5G components where we do a modular approach. So we can connect our modules to the other core network modules as well. And typically for the MNO kind of a flavor, it's not only providing the data and the voice service, and we also provide the roaming. If you wanted to connect your MNO to the other network operator, we do support a traditional roaming, very simple S6A or SCPP kind of a flavor roaming. And also we do by default, along with our IMS, we do support Wi-Fi calling functionality. So whenever you, as a part of the network, if you're not under the coverage area, and now you are under a Wi-Fi coverage, you can actually make calls and receive calls using our Wi-Fi calling module that is integrated with our network. And of course, with the 5G, now you want to segment your network for different categories. We do support network slicing. As long as the radios support the network slicing in the core network, we can support as many slices, like maybe around like 256 slices. So the key items when it regards to the core network is everyone talks about, okay, is it a 3GPP compliant? So we are 3GPP release 17 compliant and supports all G technologies here. We do have an option. We do support Edge UPF, local breakout, native voice. And of course, we are not a locked system. We have a lot of REST APIs, very standard REST APIs or something like that. So if you want to integrate for different purposes to external systems, we do have all the flavors of it. And more importantly, scalable footprint, because when you compare to others, we can support all the way from 10 users to 1 million users. And so this is one of the big differentiator, because a lot of the other core network companies, maybe they focus on only small, some only focus on very large. But we are one of the company where we support a scalable option. You can go all the way from maybe 10 users or less to 1 million users or more. And key, very important factor is because of this FWA and also private 5G, there is a lot of integrations towards the enterprise, which is mostly multiple VLANs. Can you pass on the multiple VLANs and DHCP? So you don't need to assign the IP addresses using the APN-based IP address approach, but most of the FWA operators, they prefer their own DHCP to assign the IP addresses, not a static IP address. So we do support that. and different deployment models, because depending upon our requirement, we can tailor the network, because it's not cloud or it's not on-prem. You can choose, you can build your own network, I would say. And more importantly, converged. That means today you have 4G, suddenly after 6 months your demand increases and say, okay, I wanted to add 5G to my existing network. What do? You need to upgrade? No, it's just a control over a license. So we do support a converged system as well. So this is our typical management platform, which I wanted to kind of share a high level architecture. So this is where, if you look at it, we do have all the modules that are running as a management platform. And one thing is, our management platform, you don't need to run in a cloud. It can be on a single, the Nook box I showed you earlier, as a kind of a mini forum or something. You can put the complete EMS there as well, like management platform there. So you can put it in the data center, or you can have it localized, and you can either manage single core with this management platform, or you can manage the multiple cores using the same platform. I mean, this is a typical look and feel. Once you log in to the management platform, you will see this kind of a management cockpit view. So where you see a 360-degree visibility of the network, mostly focusing for executives, like IT managers, executives, because you want to come in, you want to look at, oh, how is our network performing right now, because this is a real-time info, which I will show you as a part of management here. This is where it's very important to see if there are any active alarms, and how is your throughput going on, and then how many users are connected, how many radios are connected. So it's like a kind of a management cockpit view. So key unique differentiators, a quick summary here. Carrier grade, multiple deployment models. You pick and choose what you want. Flexible architecture, again, the same thing, depending upon the use case, the architecture may change. And converged and upgradable. And mainly key important is we do support all this network exposure function, which is a 3GPP standard of exposing all the modules outside, which is a 3GPP standard, and also the REST APIs where you can manage and control. And of course, we do have a different pricing models that our sales can work on. But more importantly, all these networks, because these are telecommunication networks, these are 24/7 networks. It's as important as deploying the network. We need to have a better management and monitoring, and also the support of the network, because we believe that you cannot switch off the mobile network because they have to run 24/7. So this is a kind of a high level view, but I will kind of quickly jump into the solutions, and feel free to post some questions. And after the presentation, I will be happy to answer those questions as well. Okay, we'll kind of focus on, okay, everyone kind of an understand, okay, there is a 4G network, okay, there is a 5G network, and I have voice services, but what are the different kind of the solution architectures that we can actually, because these are our, based on our active deployments, we prepared a very good solution, different solution architecture flavors, and which we thought it might be useful for everyone. Of course, this is something like our converged core architecture, and this is what something that we have seen before. Okay, now I will talk about, this is a kind of a typical mobile network operator, like an MNO or a small MVNO kind of a flavor. So what you have here is you have a kind of a complete control plane or a centralized control plane. You can deploy in one data center or two data centers or more than two data centers. It doesn't matter, depending upon your resiliency that you wanted to bring in, and also you want to bring in a high availability architecture. But now on the left-hand side, you can connect this centralized core that can be sitting in your data center to multiple edge locations. Now, again, from the radio side, you have an option here. You have an option where you can terminate all the data locally. So typical example is, let's say you deployed in a data center. Now your remote location where the radio site is there is over a satellite. Now, let's say, for example, that is a Starlink based deployment there. So what do we do? Because now, if you want to bring back all the connection back to the central and send to internet, your latency and jitter will increase a lot. So what we do? Yes, we bring only the control plane, but we deploy a local kind of a UPF or a packet, because since we are a converged, it doesn't matter to us. Either it's a 4G or a 5G, we do support both. One module, you can terminate all the data directly to Starlink, but bring the connections, all the consumed data information and everything back to the central. This is typical. But if you go and then pick that the box that I showed you earlier about, you deploy a radio, and then if you have a UPF inside that box, you can switch on or switch off that UPF, local UPF. But it gives you an advantage where you give a better quality of service to the end users, because your latency and jitter will reduce a lot. So users will get a better quality of service. On the other side of it, this is on the data, and then you can have a voice flavor. This is a very standard. On the other side, yes, most of the MNO or FWA networks, you need to have a policy and billing, because this is a service related. So where we have standard integrations like a 3GPP integrations, either you do a GX for data, or you can do a RXRY for voice related billing. And also you can do a webhooks based or a API based kind of a billing. So if you're running your own CRM and OCS kind of stuff, the system can be integrated using the standard interfaces for all the billing functionalities. Number two is, now you want to have a roaming option. You can connect to any operator in the world using a traditional S6A roaming. And third thing is, yes, most of the networks, they have their own home PSTN or a PBX systems. You can integrate all the PBX systems via standard SIP interface. And lastly, now a lot of networks are driven towards the mission critical services. Especially we have a lot of deployments in the Pacific Island nations like Polynesia, Micronesia. These are the places where a lot of emergency services like a mission critical push to talk and mission critical video applications are there. So it is a regulatory mandatory for us to integrate with all the government MCX or mission critical services to be integrated. So we do support these are all standards based, 3GPP standards based integrations that we do support. So primarily, if you look at this architecture, it gives a kind of a overview of how an MNO network or an MVNO network looks like. So what are the key aspects of it? Because since it is an MNO, it does need all the support of the 4G core and the 5G core, and optional user plane at the edge so that you can do local breakout. And also the UPF, you can have a simple deep packet inspection so that you can actually inspect all the packets and everything as well. And also supporting of the multiple APN. Let's say you have most of the carrier deployments, smart meters, one APN, normal consumers, another APN, premium users, different APN. So we can support up to, around like a 256 APNs or more. So that gives you a flexibility on, you can dimension your network without the actual slicing. And also because the carrier networks mostly focus on, okay, all these services, technology is okay, but because it is a 24 by 7 network, they prefer an high availability architecture, which is an active active or an active standby with a geo redundancy. And also, if you are, and they wanted to have a horizontal redundancy, which is nothing but it's called as a pooling concept. Pooling concept means, let's say you wanted to have two MME within the same core, so you can have that. So if one MME fails, the second MME will take over as well within the primary. So we do have a pooling function, which could be like a kind of a load sharing and something like that if you're looking for the large deployments. Integrations to the typical charging and billing functions and roaming. And if you look at the other part of it, typical MNOs, the MNO is mobility is very important because the users are mobile phones, and the mobile phones you are moving from a point A to point B. So you have to support the handover between the technologies and also the between the radios. So we do support all the the kind of the inter-RAT mobility and also the NSA to SA and interworking. And typically, the bigger challenge right now in most of the operator networks is the blind spots or indoor coverage. Indoor coverage, definitely, we all need to accept that the Wi-Fi has a much more advantage with regards to the indoor. In the outdoor, yes, the cellular has a much more advantage. So typically, what do you expect in the indoor coverage is you should be able to be reachable by the same mobile number. So we can integrate the EPDG or N3FW for Wi-Fi calling. It's a non-3GPP access. So once you are registered in the network, once you go out of coverage and then you are under a public Wi-Fi hotspot, you do the registration using the Wi-Fi hotspot, and then you can make calls and receive calls using the same number. And these are the mobility and interworking. And we also have a lot of, because end of the day, all the MNOs, the network need to be secured. And also we do support like a role-based access, Okta integration, LDAP integrations. All those integrations are covered with regards to the access to the system. But from the mobile subscriptions and all, with 5G, the SUKI authentication and the other authentication technologies and other ciphering technologies are popular. So we do support all the network needs to be kind of a supporting all those, these security mechanisms. And and the core also supports the narrowband IoT. If we are looking at a kind of a smart meters to connect to the existing network using the same radio access technology, because you don't want to do 4G, but you wanted to do narrowband IoT, you can actually do that as well using the same ecosystem. Integration to the other systems like the versus BSS, international voice services. This is I would say, kind of a typical MNO requirement. And last but not the least is all about the lawful interception. Either it's an offline or online, depending upon the country. Each country, even though everyone follow the 3GPP, but each country have a specific lawful interception and also location-based services demand. So, and also the most of the systems come with a EMS with a FCAPS and a KPI dashboard here. So this is a very interesting and very classic example when you are deploying a multiple, let's say this is an example of what we deployed is, if you look at it, you have a private networks that are deployed across 8 different locations. And now the customer requirement is now if my edge location, the core network, whatever the hardware goes down for whatever reason, so they want a backup of the core network to be connected back to their data center. In the data center, they have a redundancy. So if you look at it, every edge network, they have a redundancy that is sitting in the primary data center. In the primary data center, you have a HA redundancy as well. So this is a classic deployment. Now the question is, all the users are same across all the private networks. So how do we manage it? So what we do is you onboard the user in the central location, and then all the users will be copied across all the locations. The advantage is even if you move from a one location to other location, you don't have to resubscribe to the network because you belong to every network, no matter what. So worst case scenario, if the connection from the edge location to the central location is down, what will happen is that whenever the connection establishes, the users will be pushed back to the edge location. So the edge location will keep copy of all the registered users along with every other location as well. So what are the key differentiators here? The underlined items are the key differentiators with regards to the other functions or features. One is the master database is hosted in the central data center, which also have a redundancy. The subscriber profiles or the user profiles, they are consistent across all the remote locations. Unified policy and charging. If you want a policy that is defined always coming from the center, you can do that. But at the same time, the edge locations can also, if you don't want this option, you can operate them independently as well. That's not a problem because that is a typical private network offering. And every network, every location, as you see, it has their own core locally. So you don't have to, all the data is located locally, so it doesn't come back to the central location. And of course, the key important factor is how do you do the operational visibility and also across the regions where you have a central management system in this case, but you also have you can also manage the individual locations separately, but also you can manage all the locations from the central location. So this also gives you the resiliency because since you have a kind of a primary and a secondary, like a dual data center architecture with an edge-based core, so this gives a complete redundancy and also the resiliency as well. One important thing is, let's say if we go back to the same thing, let's say you want some applications to be terminated locally, like an enterprise applications, but the regular internet, if you want to bring back to central location, that is also possible. So either it's up to you. How do you want to tailor the network? You can do all the applications internet locally and only fall back to central when local hardware has some issue, or you can split the traffic between the edge and also to the central as needed. So we have an ability to do that based on the APN or based on the tag or based on based on the slices as well. So it's up to you how you want to define. The other part is how do we integrate? Okay, now you deployed a small MNO network, but now you want to use our MNO network so that the other public network users come into your network location and use the services. Yes, this is typically because our core, we have a module called a DEA and a DRA, which is nothing but a roaming module. It's a very standard, and you have your offering. But if the user from a public network operator come into your service area, you can actually register them to your network and then they can browse. So it's like a kind of an inbound roaming. So again, in the same case here, This is more like a AWS or a public cloud deployment. That's an option. Or if you want Azure, you can deploy in Azure. Or you wanted to deploy on your own data center, you can. So here the advantage is you build your network, but you want to interoperable this network to the other public network. This is something that is very possible by using a very, very standard interface here. So you don't have to deal with the vendors on the other side. It's just a standard roaming integration because you are only going to them for the subscription details. So, and typically you interconnect between the operators using the standard authentication technologies or authentication interfaces. And you do have a full roaming capability. Not only the MNO users can come to your private network, your private network users can also go to the MNO, the kind of a bilateral kind of a roaming. And we do support because the how do you define the resiliency and also the security with regard to diameter signaling is called a multi-homing technology that we use. And with regards to the local breakout and performance, yes, every core that is sitting there have a local user plane because it has a core locally so that it addresses the latency. And also the network we deployed and the configuration and the database, they're all consistent across the multiple locations as well. Yeah, this is a kind of a expanding the typical network architecture. This is a very simple way of doing it. You have a MNO 4G, let's say you have your own MNO network, which is on the left, and then we use that kind of a DRA module to connect to their DRA module. So your roaming partner network can be anyone. It doesn't matter. Yeah. Now getting back to the fixed wireless, where in the fixed wireless, you don't have the mobility and you don't have roaming. It's a very simple network here. And what you could do is you can deploy your primary core and the secondary core, and then you have multiple radio access networks across multiple MPLS locations, for example. So now what will happen is the question is, do you want to bring all the internet back to the central location? No, you can terminate you can deploy an edge UPF at every location, and then you can terminate all the data. So how it is different is because FWA or fixed wireless networks are a little bit different because our primary end customers are the CPE devices. So the typical classic example here is also about now at each and every edge location, you have your own DHCP kind of an addressing pattern. So we do support each edge location can have a different multiple DHCP servers that can assign the IPs, one for a management of the CPE and other for the internet and all and browsing. And also we do support all the VLAN tagging all the way to the end devices as well. So to summarize here, the IP allocation is not from us, is from your DHCP. Number two is if you have multiple VLANs, we pass all the VLAN all the way to the network device. As a part of we do support up to 32 VLANs here. And also our packet gateway or the UPF is capable of doing an ARP as a proxy for every CPE that is registered in the network as well. Yeah, these are the typical, if you are looking at a kind of a full-fledged enterprise grade FWA flavor, I think mostly what we believe is that these are the things that you need to consider, at least because two APNs are needed, just because so you can segment your internet browsing and management, and also about ARP proxy and multiple VLANs. I think most of the networks, they have at least minimum of two VLANs. So you can have a multiple VLAN separation as well. And also different policies. So you can have different users, different policies like speed policy or a data policy. You don't need a billing system for that. So the policy control, you can define the multiple policies, and each policy you can define the QoS for it, and then you can allocate. And of course, the DHCP integration is very important for that as well. And also supports of the VLANs to multiple services and multiple devices. And so now coming back to the enterprise, it's almost the same thing, but because for the enterprise, it's more about the um, how easy and how simple to use, and also how you get a observability of every small core network and something like that. So this is a kind of a dedicated 4G and 5G private network, and you can have this is completely deployed on-prem or data center, and then you have a primary and a secondary. And from day one, we are a CUPS architecture, control plane and a user plane separation. So if you have more traffic in the user plane, you can expand user plane accordingly. Because mostly, let's say, if you are a robotics or if you are anything, so you have only 100 devices connected, but your throughput of these devices, because the use case is all these are robots or like a camera devices, so it is consuming a lot of packet data. So in this case, if there is a demand on the packet data increase, so you can upgrade or you can expand the UPF as well, or you can add another UPF. So this is a kind of a typical, very dedicated 4G, 5G private network. You can have, so primarily we are a believer in redundancy. So we don't recommend a network without a redundancy, because most of the networks are prone for outages. So and it's better to have at least an active standby kind of a setup, so that the network is secured with all the other disaster recovery mechanisms. And more, and also, of course, we talk about how do you connect between the radio to the core. Yes, you can. It's on IPsec connectivity. If you prefer an IPsec, it's all about IPsec all the way from the radio to the core. Or if it is in a very controlled and in a very they are next to each other, for example, in that case you can connect directly, but the security aspects of it is pretty much covered, because the design, if you look at it, because it's a scalable model, like that's why we separated the control plane and the user plane here. So depending upon the need, you can scale accordingly. So this is one of the use case where this is where it's not about the downlink. This is a use case about the core network, a redundant core network that has been deployed in their data center and then connected to their firewall and a switch, and then it is connected to the multiple radios. So the use case here is it's a camera use case where camera is continuously streaming uplink traffic, and the requirement is also about uplink data throughput should be around 250 or 300 meg. Of course, downlink is not a big criteria here. So number one, that is one challenge. Number two is the mobility, because these are moving devices. These are race cars, for example. And race cars, because the mobility is very important, right? They're not going at a 100 miles per hour or 50 miles per hour. They are going around, like 200 plus kind of miles or kilometers per hour. And also it needs to hand over seamlessly, because if the device is moving at that rate and which is moving between the devices, very heavy uplink video calling and other things, because here the more important, downlink is easy, but uplink is very much kind of important here. More importantly, because the streaming needs, it's a real-time streaming, it's a very ultra low latency as well. So how we were able to achieve this is, yes, of course, here uh, we um, we use because a packet gateway, every packet gateway, if you want a more like a carrier grade packet gateway, you need to leverage the DPDK and VPP functionality for all the acceleration techniques. So in that way, we can actually perform all the functions of the UPF, so it will address your use case as well. And there is something very specific that we found out, that there is a DSCP marking in the UPF. It is very important to avoid all the frame rate loss and everything else. So most of the deployments are downlink priority, but this is one of the classic example where these are not like a standalone or the camera devices. These are moving camera devices continuously streaming traffic. So this is where one of the use case that mostly, if you come across this particular thing, we are happy to kind of work with you on this one, because we see a lot of modifications that needs to be done to make sure that the end users will get a good streaming traffic. So when we do the edge breakout, how we do is this something like this. As I mentioned earlier, that means when you do a local breakout, still there is some signaling traffic coming back to the core network, because when you do a local breakout to the local UPF, the user is consuming a lot of traffic. But from the core network perspective, you need to understand how much data he's consuming, so that you can assign a policy. So here, if you look at it, what is happening is all the data is terminated at the edge, but there is a connection back to the core network, which is reporting the data. So the UPF is reporting all the data back to the core network here. Number two is, what will happen if the edge UPF or edge packet gateway goes down? Then the radio will send all the traffic to the central UPF, which is using the N3 interface. So the option of the local breakout is, it is not only giving you a local resiliency and also the load sharing, but also giving you a kind of a redundant architecture for you with regards to packet data. So embedded code. This is something that mostly now we talk about the radio and the core separately. And this is the embedded core, where you have the 5G core, 5G radio, all the features and functions that we just discussed about are included along with the management platform as well. So and what we just need is the power and the internet access to it. So now what will happen? So this is a classic example in a factory where you deployed multiple of these boxes. So let's say you deploy two boxes on each side of a factory. Now you have a user that is moving from a box A to the box B. So what will happen? The session will not terminate. So we have enabled a kind of a functionality where you still keep the session. If you are deploying multiple of these boxes across the different locations, like a factory or anything, you should be able to seamlessly move from one box to another box without disconnecting the session. It is not even a pinch of a drop where that means the session will continue because we do a communication, more seamless communication between these two. And the other thing we talked about is also about how do we integrate with the mission critical services. So think about the RAN in the core sitting in the middle here. So we have been working with a lot of MCX mission critical providers where we do all the integrations, and it's a predefined stuff that where we do support all the different MCX related use cases, because MCX is not just about push to talk or a video. There is a dispatcher, there is a train management system, and a lot of other things as well. This is a kind of a typical interface related architecture, how our core is kind of a connected from the MCX UE, like a Tetra device, for example, that is a mission critical UE, is now it is connecting to the mission critical application. Here, you don't need an IMS, for example. You can have an IMS, but without IMS, you can also do. But here, if you look at the key important factor to notice is the all the default internet is a non-guaranteed bitrate bearer. The bearer is very important. So it's a very standard and internet and also the signaling. But the all the MCX really the every media, either it's a push to talk video or push to talk call, it has a dedicated bitrate which we have to pass on that bitrate back to the application server. So we have a pre-integrated MCXs and all. So depending upon the use case here, I think we do support multiple different MCX use cases. And also one other thing that we also notice that even though it's a fixed wireless or a private 5G, you have your own internal PBX systems where typically the SIP supported. So we can actually connect all the natively connect the PBX system. So you can make a call between the mobile devices and also the PBX devices as well. Yeah, it's a kind of a high-level solution document which we will share with you. And any question, happy to answer, and you can post it in the chat. And then after this presentation, we will be talking about all these things as well. So I'll quickly jump into the EMS demo so that can focus on the other things.
Naren, are you logging? Shall I share the screen, Naren?
I'm logging in.
Okay.
One second. Okay, I'm just sharing my screen. Okay. So this is a typical login page that you can also customize. Every customer can customize their own login page. So it's a typical URL. So you log in. So I'll just log in as admin in this case. So I sign in. So once you log in, you get to see this kind of the management visibility that I mentioned. So if you look at here, I'm here, you can see the number of subscribers that are kind of a onboarded in the system, and also all the subscribers will have the voice over LTE functionality. And of course, we also have, if the phones doesn't support VoLTE, we have an ability to install a SIP app on the phone, and then you can use it for communication as well. How many radios are connected, how many active users on 5G, how many active on 4G, and also how many eNote Bs and active users. So this is a kind of the uh, platform or a management cockpit that you could see. Then this is the real-time throughput of the UPF. So we do support multiple UPFs. For example, you can select which UPF you wanted to see. If there is no data, it shows like this. Because the first one you have the data, there is some data going on in this particular primary UPF. So you get to see all the, and also for this particular UPF, you can see what is the 24-hour, 7-day, 30-day kind of the stuff as well. And a key, I mean, there is one alarm. If you look at it, okay, major alarm, I can click and then it goes to the alarm and it talks about, okay, there is a memory alarm or whatever it is, then I can go to the view, what is it all about and other things. So when you log in, typically you see, you get to the screen where you get the visibility of the network. Now, what I will do is I'll first, before you log in, right? So what you do, now you as an admin, you log in. So what we have an ability, we have a role-based access. So I go to the system security, and then, for example, here, and then VPN. One second, my VPN is slow. One second. Father, can you log in quickly?
Yeah, sure, Naren. 1 minute.
Okay. So anyway, it's okay now. So I just,
Oh, okay.
so yeah. So first thing is, once you log into the system, you wanted to first focus on, okay, who are my users in my company? And then how do I define the roles? Here, our management platform is all designed like build your own kind of a management platform. So how what it does is, so we can actually do the role management. You can start with the role management here. You can create as many roles as you want, for example. So let's say, for example, I have a general user. So I click on this particular general user or whatever, and then I edit. And then I can actually control, as an admin of the company, I can actually control which menu that I would like to show and which menu I would like to hide from them. See, if it is a general visitor user, I wanted to only give him an overview, and also I wanted to give him an overview of the network performance only. So you can control as many, you can define as many roles as you want, and admin can create all these roles accordingly. Now, once you have the role management, and then you can allocate the, you can assign the users, for example, here, and then you can add the role to a particular user here. And also, if you don't want to manually allocate, you can also do an LDAP. As I said, I mean, in this box we don't have an Okta, but we can also support a LDAP or a single sign-on like an Okta integration as well. So you can define your own roles, your own users, and then you build a management platform, what you want to show, what you don't want to show accordingly. So this is the user. We will get into the tenant later on, but there is also, you can create multiple tenants depending upon the nature of your tenant. So this is a typical kind of the user management that you would love to go and then manage your own as well. So once you have defined the users, now you got the system. Now you wanted to do you have the IP address and everything. You can do a uh, uh, kind of a quick setup here. So you see here, you don't have to do anything. So you can fill all these elements. You can select either you want a light UPF or a standard UPF, which is a DPDK based driver we have to define. And this is where you define the APN for the IMS and everything else. And then this is where you define all the IP addresses for all the network elements. And you can configure very easily here as a quick setup guide. So once you configure as a quick setup, and now you can go to the NG management, and you can actually, you can edit. You see here, I can edit, and the first thing, once you get into the system, you can allocate the IP addresses. Once you allocate the IP addresses, you can actually, mm, Jaya, maybe you can try to present, or Kader. Yeah.
Yeah, sure. I'll let me share my screen. Yeah, is my screen visible?
We can see Kader.
Oh, okay. Yeah. So this is the NE information. You can see all the NEs, what are the IP addresses, and you can, if you want to do a quick restart, you can do a quick restart from here, and you want to stop and start the process, which you can do here. For example, you can also do the config export and import. And for example, if you want to change back to the old config, you can upload the config also from here. And we have the NE license where it shows the license status of all the modules. So what is the expiry date? So every application will have its serial number. So how many UEs you have, how many radios you have. So you will see all the license related information. Let's say your license expired, or if you want to upload a new license, you can also do the license management from here directly. So you can upload the license directly here. And you have the any software version here. So always we maintain two software versions you can maintain in your system. So one is the current version and another one is the previous version. So let's say for the UDM, I have the current version of 2.25.11.29. So this is the current version. I recently upgraded and I am having some issue. So I want to fall back to the previous version. So you can simply go here and you can check. So switch back to the previous version. So confirm switching to the previous version. Now the software, everything will roll back to the previous version. So for every modules, you have that facility. And I'll quickly go to the quick setup. Sorry, the any config. So it's all the advanced config. So first we will discuss the parameters from the core, which will talk to the radio. So let's check the AMF module. So in the AMF module, so here is the place where you configure the P elements, because these P elements should match in radio and the core. So we support up to 16 P elements. So here you can see the list of P elements which are already configured: 00101, 315010, 99999. So those are the P elements which are already configured. So you can quickly add a P element here which matches the radio. So this is the place where you configure. And also you can have the tie list. So this tag, either it's one or whatever the tag, so it should match with the radio parameters which are configured in the Baicells radio. So for example, you are using 99999 P element and you want to quickly add one more tag. So you can update the tag here, which P element? 99999, and you want to update the tag, let's say 100. So the tag has been added. So if the radio with the same PLMN and tag connects, it will be automatically integrated to the core. So in the AMF, one more parameter which related to the radio is the slice list. For AMF, so we have a default slice parameter, SST and SD. So this slice parameter also has to match between the radio and the core. So you can quickly set the PLMN and you can modify or add the SST and SD and you can set it. So these are the three parameters which you can manage from the core side. And if it is in sync with the radio, radio will be automatically integrated. So these are the parameters which are facing towards the radio. So I will show some advanced configurations. So we have one feature, it's whitelist feature. So let's say you have a CPE, you are running a fixed wireless access and you have a CPE. So you want only your CPE devices which are authorized by you, you should work. When you insert a SIM card in that CPE, it should work. And when you use any unauthorized mobiles or other phones, it should not work. So we have a EIR. We can do the whitelist. So let's say here, so I have a IMSI with 315010 and I have a IMEI value matching. So when you insert a IMSI in a device with this IMEI value, then only the device can register to the network. If not, it will never register. So in this way, you have control what are the devices that are connected in your network. So similarly, let's say this SIM card, and I have given a IMEI value prefix. So any device with this prefix IMEI value, yes, we can connect to a network, to our network. So in this way, we can have the control over devices as well, and we can eliminate the unauthorized devices not to connect. So this is the whitelist. And how many APNs we support? So we support multiple APNs, up to 1000 APNs we can do. And APN can be easily defined in the UDM. Here you go EPS APN. So already the APNs, internet, IMS, Blue Arcus, management, all are defined here. So you can quickly add a APN, change the APN name, and you can create an APN. So now I know
Here
how
you
to
can
create the PLMN.
stop. Yeah. Mhm. I
Hello?
think the screen was stuck. You can stop sharing and share again.
Ah, okay. Is it visible?
Yes.
Yeah. So in this way, we can add multiple APNs in the system. So now let's go to the PCF. So in the PCF, this is the place where we configure the special PCC rules. And if you want to give any priority to some customer or some specific IMSI, you can set the rules here. So this is the way how you prioritize the traffic. So let's say here we have the PCC rules. So I have defined my own rules for the internet traffic and my own rules for the IMS signaling traffic. So this is the way you can define your PCC rule here. So what is the QoS ID? So you can define your rule here. 1 minute. Yeah, and these are the session rules. So now I want to control the bandwidth of the session. For some users, I want to give only 5 Mbps, and for some users, I want to give unlimited speed. So those session rules can be configured here. And you can see some users here are with 5 Gbps, 1 Gbps. That's the maximum bandwidth core will pass. And for some users, if they are out of credits or out of recharge, we can still able to make them connect, but with a little amount of speeds, 200 kbps and 100 kbps. In this way, still they can have access to do the recharges, but they cannot browse the very big volumes of data. So these are the PCFs. So these are the quick advanced configurations, which if you have in this way, we can manage all the modules and we can configure that. And after that, so your core network is ready and you have set up all your configurations and radio also connected. So now how to add the user? So you go to the UE. We have multiple ways of onboarding the users. So here is the place UDM authentication where you add the KI values. So you just click on the add and you onboard your IMSI and what is your KI value and what is your OPC value. You set all these values and you can add the IMSI. You can add the authentication parameters for that IMSI. And for example, if you have like 5,000 or 10,000 in a bulk, so you can always import it in a CSV format. That option is available. And you can also export all the data from our system. So once the keys are onboarded, next you go to UDM subscribers. And here is the place where you actually design your customer profile. So let's say I will add one user. Now for that user, what is the SST value? And what is the SD value? What is the APN you want to give? And if you want to allocate any static IP for that user, you can also set the static IP. And also you can create some more profiles, go in depth. So how does that profile should look like multiple APNs. If you want any roaming restrictions, you can put the roaming restrictions here. So you can design your customer profile here. So you can add, and similarly, if you want to add in a bulk, you can always use the import option and upload a template. It will be created. So for one go, we can onboard up to 10,000 subscribers in less than a minute. So that's how to onboard. And also there is a third way. So we can also onboard the API through onboard the customer through an API. So we expose the REST API. This I will go through it later. So from an external system also, you can control onboard the user and delete the user. I will show through the API format. So in this way, we can add the subscriber and let's say the customer got attached. So once the customer got attached, now you can go to the field online information. Here you can see, okay, I have now 2 mobiles connected. So these are the live sessions. So that's why it's online information. So when you click on the session, here is the place where you are seeing the actual IP address. So this particular user, he has an internet session with this IP address and also has a IMS session with this IP address. So let's say you want to test is this real user or not. So we also have an option, just ping it. And from the EMS itself, you can be able to ping the UE.
Yeah, typically this will help you to understand the latency with regards to the particular session, how much of the latency,
Yeah.
because you may have 100 devices that are connected to the network or 1,000 devices, but the goal is to understand that whether this particular UE has any latency or jitter, or if you doubt that it has a latency or jitter, you are able to kind of perform this test, and I think based on the result, you can actually kind of make a decision for this particular user.
You can see the packet loss is 0 and it's 59 milliseconds. So in this way, you can also directly ping the UE. So this is the place where you can see how many radios are connected, which radio is online and offline. So we also have a PCF user management. where in the PCF user management, here is the place where you give priority to your subscriber. Let's say this is the IMSI, and you can have your own customizer PCC rule and the session rules tagged to this user. So this user can have higher bandwidth or lower bandwidth or special priority in making the Vivo IP calls. You can define the user. So these are the places. And also one more thing is on the SIM card. So we also support the Suki SIM cards. It's like a subscriber concealed identifier. So this is like a security where we are adding it in the 5G. So if you see the Apple documentation, without these Suki parameters, you can never have the iPads and the Apple phones connected to a private network. So this Suki we support, and also the eSIM we support. So most of all the iPhones now having the eSIM. So we can also support the eSIM where we can connect to the SMDP platform and share the QR code. So the moment you scan the QR code, you will be onboarded to the system. So these are the options. So next one is I'll cover the multi-tenancy. So here we have a tenant management here. You can see already in my system, there are two tenants configured. So I have a tenant 1 and tenant 2. So when you click on the tenant 1, so first of all, how do you define a tenant? So I have a customer, I am onboarding him as a tenant. So what we are offering? We are offering the particular SIM cards to that customer. And if it's an enterprise, we can also have a dedicated UPF allocated to them so that UPF can do the local breakout. You can also give multiple radios. So these are the assets of that tenant. So similarly, you can have the another tenant. So you see this tenant has SIM cards and UPF as the assets. So in this way, what are the assets our tenant is purchasing? You can add all those tenants here. So here my tenant has two SIM cards. Of course, we can have multiple, or you can define the prefixes also. So now when you log in as a tenant, so you also should give some access to the tenant, right? So what I will do is I will log out. So now I am the tenant 1. So I will log in as a tenant 1 into the system. Since I am the tenant 1, 1 minute. Yeah. So now I log in as the tenant 1. So since I am the tenant, what are the assets I purchased? I should see only those data. Yes, I have a radios. So here you can see the radio information, and I have the SIM cards. So out of those already I have two sessions connected. These are the online sessions. What are the SIM cards that I have purchased, and the CDRs, and also the UE events, which UE was connected and when it was disconnected. So only the tenant can see what are all the assets that he purchased. So he purchased two SIM cards. He can see the two SIM cards here. And if they are using the internet, you can also see the throughput here. So this is the tenant. He cannot see any other data, only the data what he purchased, he can see that. So now let's go back and log in as the admin. So now you have onboarded the UEs, you have the active users connected, and now you want to see how your users are performing. So let's go to the KPIs. So before going to the KPIs, you can see every module in our core network, we are generating the KPIs. Let's say for UPF, we have almost 11 KPIs. And for IMS, these are the KPIs like call success rate, setup time, MOS score, all the KPIs. So every module, we have a set of KPIs, almost 150 KPIs we have. And for the AMF, what is the session success rate, mobility, handover success rate. So you will have all the KPIs on the mobility side for the AMF and the MME modules. So these are the KPIs. Now let's look into the system. So here in the performance, you can see the voice call dashboard. Actually, this is the live data. I have some devices which are making continuous calls. So you see all the calls behind, they are running automatically. And so you can see the MOS score here, it's 4.24. And you have already the busy hour call attempts 5. So call completions also 5. So you have the complete data here for the voice dashboard. So in the past 1 hour, we have around 65 calls connected. So this is the voice dashboard. And now we have the other dashboards as well. So the KPIs. So every module you can select the data query. So let's query till yesterday. And you have the KPIs generated. So you can select the module here. So let's say I select IMS. And then these are the IMS metrics. How many MO call success, MO call attempts, you can see it here. And we have a customer indicator, custom indicator data as well, where you can define your KPIs and you can monitor those KPIs as well. I don't want, hey, you are giving like 150 KPIs. I don't want all those. I want only a particular set of KPIs. So you can define those KPIs and those you can monitor. Let's say the MO success rate here is 99.01, MT success rate 98.69. So we are not doing the IDD calls. So in this way, we can monitor your KPIs.
Yeah, Kader, I can continue the KPIs and also the tracing quickly so that we have
Sure.
only 30 minutes more. Okay.
Yeah.
Let me share my screen. Okay. There was a question about how do you search for a particular tenant because you have hundreds of subscribers. So what we do is, let's say, for example, you go to the UE. Okay, I have a lot of devices right now here, and then I can actually search based on the tenant name. Let's say I have tenant. So this particular tenant, I have two users defined. I have another tenant, I can search clearly, and there is a one user defined accordingly. So in this way, you can search all the devices or all the users that are allocated to a specific tenant. But there are also a lot of other devices where no tenant is allocated. That means those are very kind of a common subscribers as well. So what I will do is I will kind of a quickly focus on the performance, which is a kind of an important function when you are running a network. You wanted to know, okay, you have configured the network, you onboard the users, the network is operating. And this is a kind of, I would call it as an observability platform. Like how do you know how your network is performing in real time? So this is if you have the voice calls enabled in the system, you can see all the voice call success rate, registration success rate, and everything. And this is a overall network stats. Like you click on this one, and where it will define the overall network stats that we think that are very kind of an important or something like that. So mostly uplink data, downlink data, key important stuff. And this is the key performance reports based on the module. Let's say you want to have, okay, I don't want IMS, for example. I just want maybe AMF, maybe not even this one. So I will just want this. So I can actually only get the data of UPF. See this one. So what is it? I mean, maybe what we call it as N6 and N3 is nothing but N6 is the data that is going from the packet gateway or a UPF towards internet. N3 is towards the radio. So you can see if there are any drops in the system or anything. And this is the metric. You can also have that data here, which is you can export it and you can build your own dashboards. That's not a problem. This is the reports, and this is where you have all the indicators with regards to all the all the packet data. Let's say, for example, you as an operator, as a service provider, you wanted to define your own dashboards. So that's where what we give an option to the customer is mostly admin can do that. Customer indicator management. So where you add what you want. So you can select like this. This is the one that our team added, our test team added, where basically I wanted to get the visibility of all these particular, uh, KPIs. So when you log in, you'll see the customer indicator management and the customer indicator data. I will only see the ones that I kind of added here with, let's say here, if I go back here, I'll pick IMS as such. And there is, and one, two, three, total number of 6 KPIs that I added. So that is important for my business. Now I go back to the customer indicator data and then I select IMS. You see, I only see those 6. So that means you can also do graph base or you can do all the database. So this is very important for a customer to build your own dashboards, and you can look at all the overall network stats or the custom based stats as well. Now for other for whatever the use case you wanted to see, I wanted to know, for example, one particular user, how much data is being consumed by this particular user. So I go to the UE, I look at the online UE PDO session, for example. I look at this maybe the data. Okay, let me go back. Performance data usage report. So I can use a subscriber data, and then let me see what user I can use to test. 1 second. Okay, I'm going to use the user 40. Okay, just copy paste. This particular user I want to test. See, if you look at this one, I'm testing the data usage report for this particular user for a specific period of time. So from whatever the time, you can have a data uplink and data downlink specific to that particular user. But if you have multiple PLMNs in the network, and you can say, okay, I wanted to know what does the 00101 consume only, for example. So this is specific to all the IMCs that are doing this particular IMC as well. So this is the typical KPI kind of a management. There are a lot of things here, but I think I will now switch to covering. Now you have configuration, you have performance, but there is a problem in the network. How to troubleshoot the problems in the network. So what we have is we have something called tools in our system. In the tools, the first thing is once you bring up the 5G core or a 4G core or anything core, and now you need to make sure that the core network can be accessible to the internet. So what I will do is I will do net probing test. That means I want to make sure that I'm able to, from my packet gateway, let's call it as a UPF here, for example, and I would like to ping DNS, which is a Google DNS. So let's see if I can ping. So if I get a response, okay, I'm going to get a response from Google DNS. That means my core network is able to access to internet. So this is fine. Now I can also do the iPerf test, which means if you run a client, you can be a client or you can be a server in this platform, and the other side can be your device. So your device can run a performance testing for throughput. So if you become a client, you need to enable that as on the device side of it, you can make it as a server and you can run, or device can be a client and then you become a server, and then you run the hyperf test, depending upon whether you want to do a downlink test or an uplink test here. So the now this is where you check whether you can ping other elements, you cannot ping other elements, or you can ping internet, or some specific application that you are performing. You need to make sure that it is reachable. So once you have the network, now I have a signaling capture. Signaling capture means I would, let's say if I wanted to capture the traces on AMF, for example, I can click on the AMF, I can run and I say, okay, and it is capturing the PCAP, and then I stop it, and then so it will stop. Now I can download to my PC and open it. So these are all the historical captured files that I could say, let's say I select AMF. So then these are nothing but the PCAP files that you can download, and you can see where is the problem. So let's say you already have these PCAPs that are captured on the per modules. For example, here I captured the AMF module because maybe AMF to the radio, the link is not working. So I've captured. This is fine. Now I want a signaling analysis. So what I do is I don't need to download to my PC and do all those other things. So what I do is I upload something from my system. See, I uploaded something from my system, and then I can actually analyze all the PCAPs here itself. So, so this is one way of capturing the file, and then you can look at all the historical captures that we have made, like let's say AMF or MME, anything that is there, we can actually capture all those items. So and there is another thing what we have is a trace task. Trace means, like let's say if I add a thing, I have three different traces. User tracing. For a specific user, I want to do trace. Module tracing. I want to pick a module, which is AMF, for example, or SMF or packet gateway. I can specify a specific module and do a trace. And if I wanted to do a specific interface trace, that means then I can say like S1, for example. S1 is an interface. S1C is an interface between the MME and the radio, for example. So you can do interface trace. So the team already done the tracing before. So what I would like to do is I would like to show. Okay, in this IMSI tracing, okay, we collected the trace and the trace is stored here. What I will do is, why don't I just do the analysis here? So I don't need to go to engineer to tell me where is the problem. I can actually see here what for this particular IMSI trace, there is a PFCP deletion request, deletion respond, and deletion, all those things. So we were able to capture like for IMSI tracing. Now this is the interface tracing. So I can do track data or track data analysis. That means it will do automatically the analysis for me, all these items. So you can see what happened, where is the problem, whether it is sending the right APN or not. So you should be able to do that. And the same thing goes to the module tracing. So if I want to know, let's say for this particular example of IMSI tracing, I go and then I look at view. Means what did my engineer do for tracing? So what he did is he did the IMSI tracing. He wanted to do the tracing on AMF and SMF only. That means this particular subscriber is being captured in both AMF and SMF at the same time. This is the user tracing and the time. That means you can schedule it. If you want to do the trace tonight, you can schedule it today, the task time, and then you tell which number, and then it will automatically do it and it will store here. So anything, it doesn't matter. Either it's a user. If it is an interface here, I have interface. So the engineer performed the interface tracing for AMF. That means anything that is connected to AMF, we capture. And this is interface. And if it is a specific signaling interface, they want to capture only N1/N2. So it will capture during this time. So you can schedule the tracing as well. And at the same time, you can see the trace data, all the trace data, because there is no analysis. But if you want analysis, you go here, you click, and then here is the analysis. Oh, sorry. This is the analysis. So it not only gives the event info, but also gives you the PCAP info right here within the system itself. So I can see all the protocol info, everything. So what happened and everything. So you don't have to download this and do on your PC and all. So it gives you a more visibility on how you can actually run the trace, and you can schedule the trace, and you can do an analysis of the trace as well. So this is the kind of the stuff that we have with regards to the tools. And of course, we have all the logs, events, alarms, and all. Let's say operation logs. Typically, most of the logs are being defined here. See, right now, whatever I have done as an operator, as a blue Arcus, I did a signaling capture, and I did a whatever all those things are collected, and it can be exported automatically to your Splunk, for example, for any auditing purposes. Security logs. Security logs means which is my account, my login address, my mobile operating, I mean my device operating system, my browser, so I can get the info about all these things as well. So of course, alarms, events, logs, everything can be kind of a transferred. And the other one, last thing I wanted to also kind of a point out here is, end of the day, you need to, if something happens to the system, you should have a backup of the system. So we automatically create a backup every night. And then you can actually set up right now here, you see setting a remote backup service. So you can set up a backup. So the team already set up a backup. That means from the management platform, it is sent to external machine, and then it saves in a directory called temp folder in a specific directory. So not only the configuration, this is all the users in my system, for example. So they have been again did a complete backup here, like my subscribers, all my authentication, for example, all these things can be stored here, including the CDRs, which is very important for the mobile service provider, because you need to share the CDRs. Logs, this is something that you can send it to your Splunk. I want a system operation log. I want to make sure that whatever all the logs, I can send it back to my external system, and also the KPIs. So if you want to build your own KPIs and external tools like dashboards, BI dashboards, typically, also, we can automatically send these every time the backup is generated every day. We will push all this data to the remote backup as well. So yeah, I think typically, I mean, there is a lot of other things, but I would like to, kind of maybe take any further things that you would like to see in the system, which I think, let me see. Okay. Okay, PCAP trace, make a PCAP trace to an UE? Yes, of course. I think that is the one that I kind of mentioned earlier, like you go to the tools, and then I do the trace, and then the trace task, and then this is based on the IMSI here. Any other questions? I think maybe, I think so far we have covered most of the high level stuff. And thanks everyone. And now I think we are open to any Q&A. So we can take like next 15 minutes to have a Q&A session. Anything, any specific thing that you would like to see, we are happy to kind of talk over it and present that as well. I would like to any questions or anything?
Yeah, I think Naren,
Uh,
we need to allow them one by one the mic.
okay,
So yeah,
okay.
if
How do I?
anyone would like to like talk, I think you can raise your hand and I can allow the mic for you.
I do see one question came in. Yeah, for the QA.
Okay. Jesse, I don't see any new question.
There's a
Okay.
QA.
Can you
Yeah.
describe? Okay.
Okay,
API.
I can
Yes.
read it out
Okay.
too. It says, yeah, can you describe the API structure? Yeah.
Yeah. Sure. Sure. Yeah. Absolutely. I think what we would like to do
I,
is, I think, Kadir, can you share the
yeah,
Swagger
I will.
and the
Sure,
API?
I'll do
Okay.
that. Yeah.
Yeah. So, Lucas, I think the question is the
I'm
API
sharing a 1 minute.
structure for the code. Yeah. So we have the API document, and also for convenience, we have a Swagger API. So anyone can actually log into the Swagger and then perform all the related functions and the data points. I think my colleague Kader is going to share right
Yeah.
now. I think Kader first share the
Yeah.
API Excel sheet
Yeah, sure.
and then go over stuff.
Yeah. So, so this is our complete API, total list of the APIs we support. So these APIs include every module data, KPIs, metrics. So every module we have a set of APIs. So this is the complete, even you can onboard a user, you can delete a user, you can also do the configs using the API. So almost we have around 100 APIs. So these are the complete set of APIs. So this is like a total list. So now let's go to the actual portal. So what we have done is, instead of an offline document, this is kind of an online document where you can refer the API structure and you also can try out some APIs. So here, whatever the APIs you are seeing in Excel, we have all the APIs here. So before trying out an API, so because of the security reasons, we always issue a token to you, and using that token, you can query the API. So let's say this is my login API. I have executed it, and yes, the result is success. And in the return, I got a token. So now what I will do is I'll copy the token and I will authorize myself. Okay, so now I am authorized. So this we issue token for every 2 hours. So now for the next 2 hours, you can try out whatever the APIs you want. So you want to see the version info, or you want to see the resource utilization, hardware information, whatever Naren showed the KPI, you can pull all the KPIs into a Excel and you can download. So this is the AMF data and this is the IMS data. These are all the MME related KPIs. And let's try out one API. So you have a UDM subscriber here and you want to add a user via the API. So now what you will do is there is a post API here, UDM subscriber profile edition. Okay, now I am here. So you want to try it out. So just go for the data. And this is the exactly the parameters which you need to fill out. Let's say your customer has you click on the try it out and then go for the data. So you want to add this user. So now you can verify these are the parameters you need and you execute. So once you execute, you will see the response. This is what the response you expect from our system. So it says, yes, MSISDN already used. So if it is used, we can change the MSISDN and we can try it again. So you see now the command is success. So the user has been added successfully and this is the response you got. So once you get the response message, that means your subscriber addition successfully completed. So in this way, you can, this is your API structure. You see the curl-x post message. This is what the API structure you have to fire. And this is what the response you are expecting from the system. So every API you can try out like that. So these are the bunch of APIs which we have. So network information, including the CPU, RAM utilization, every time you can pull all the data from our EMS. So in fact, you can start and download the packet capture also using the API. So any question on the API?
Yeah, we would also share the API and the KPI documentation as part of the package.
Yeah, hi everyone. Is there any other questions? I allowed mic to everyone, so I think you can try to speak if you have questions. Yeah, Naren, there is one question. Is it possible to make a pickup trace to a UE from Miguel? I'm not sure if that has
I
been
think
answered.
I think we have covered that, right? So
Yeah.
basically,
Okay.
the IMSI tracing kind of the output is the PCAP trace and the log as well, both.
Thank you very much.
Yep.
Okay, do we have any other question? Or if not, yeah, Naren and Jesse, maybe we can do the closing remarks.
Yeah, I saw a number of people looking for the recordings. I'll get with Paula just to make sure whether it's recording or I think that shouldn't be an issue getting the video out. And then yeah, so I'll work with her to make sure everyone gets a copy of that. But yeah, otherwise, from Baicells side, yeah, thanks to everyone who participated, and if there's any further questions, you can always reach out. I'll actually put, yeah, I guess part of the reach out, we'll do a follow-up. I'll send my contact information there as well, in case anyone has any further technical questions afterwards. But yeah, glad to see healthy attendance, and thanks a lot to Blue Arcus for also joining in this.
Thanks, Jesse, and thanks everyone for joining the presentation and training today. And happy to answer any other questions, as Jesse mentioned. Yeah, please send us your queries, and then we're happy to answer.
Okay. All right, I think that's a wrap then. So thanks everyone. Have a great day.
Thanks, everyone.
Thank you. Thank you,
Thank you.
everyone. Have a good day. Have a good night.
Okay, bye.
Thank you.
Thank you, everyone.
Thank you.